So as time moves on, we find that we have electronic control units or engine control units or control modules, electronic control modules, whatever you want to call them. We find these ECUs are starting to be fitted to our vehicles. The engine control unit, the engine electronic control unit was one of the first ones to be fitted, and a lot of that was to do with the emission controls that we needed to effect to try and clean up our atmosphere. The other reasons for it was because we wanted to try and get as much power as possible out of a small engine as we possibly can. That way we can get more power because we've got less weight. We can also, if you're a commercial vehicle, you can carry more things if you can use a smaller engine and get the same amount of power, which means you make more money. So this was absolutely crucial, but it did change the way that the vehicle starts the engine. And I'm just going to take a little bit of time just to go through that. So you see here, this is how our this is how our mechanical system worked. We would use a relay and we would use a set of mechanical switches, including the ignition switch and also including the transmission switches, clutch switches, seat inhibitor switches. We've already gone through those, but most of those would have been mechanical. We then introduced the engine ECU, and you can see straight away there's a couple of changes. The first one that you'll spot is that the ignition switch here is no longer carrying the power directly to the starter motor. What we've actually got now is we've got the power going directly to the starter motor if we follow this cable down through here, but it gets stopped at a relay, the starter relay. Only once that starter relay is activated or the contacts are closed within that relay can the power go through to that ignition switch terminal. So a little bit different on how this has worked before, and we've also, if you notice, we've also got a crank sensor in here. Now this isn't the only sensor that comes in here, and the engine ECU was obviously responsible for operating injectors, if it's a petrol vehicle, operating the spark plugs as well. So there's a few other functions. I've just kept these functions down to what the starter motor required for its function to be able to start the engine. So down here you'll see that once again we've got our ignition switch. It is no longer a switch to be able to switch power. It is more of a manual sensor. There's power coming down to the sensor, to the switch. When the driver would operate it, it will send a signal back up into the control unit so that the engine control unit knows what it is operated on. Now obviously we can talk about vehicles, but these things can be fitted to generators, air compressors, anything that's got an engine that also has an ECU. So it's not just about vehicles. So once the driver puts that switch, that sensor into the crank position, power can then power or a small amount of current goes up into the engine control unit, which tells it that the driver is wanting to start the engine. What we then find is that the engine control unit will then send power down to the relay. That current flows through that coil, that electromagnet in there. It will then energize and it will close the contacts, and the starter motor begins to crank. One thing that we had with our mechanical systems was it would rely on, once you've cranked the engine, once the engine started, you would have to let go of the key. And failure to do this could cause a lot of damage to the starter motor. So in this system, we don't have that direct link with that key. We also want to try and protect the starter motor and the engine the best we can. So what we then have is we have this crank speed sensor. When you crank over an engine, the engine might crank at about 200 to 300 RPM, but when the engine starts up, the idle speed for the engine might be anywhere from 500 to 800 RPM. So the ECU has information feeding back from the crank sensor, and the ECU will then interpret and basically figure out when the engine started. Once the engine started, it will then disconnect the relay, or it will prevent the power from going down to the relay. The relay de-energizes, the contacts open, and then the power to that solenoid on the starter motor is no longer. The starter motor stops work. The starter motor is no longer operational. So basically, that's a quick overview as to how our electronic control unit operate our starter motor. So that's a basic overview as to how an electronic control unit operates with a starting system. There's a lot of vehicles out there that will run just one ECU. So things like generators, air compressors, some of the marine applications, ag, earth type applications. Some of the early vehicles as well would have only had an engine ECU. So that's a very quick overview as to how they operate. It should also be remembered that if you've just got an engine ECU, they might also have some of those inhibitor or safety switches fitted to them to prevent the vehicles from being started. So, you know, again, this is just a general overview. You're obviously going to find different systems out there with different components fitted to them. But in general, in a basic view, that's how they're working.